So in case you are preparing for exams in the basically on the concept of the mechanics, and now this video is good for you. In the way I will be looking at what they call as the concept of the linear motion, we'll be looking at the typical applications, just part of it, and also be looking at what they call as the two-dimension motion, and we can finish up with what they call as the relative motion. But don't forget to subscribe to the YouTube channel, and that bears on MGB Analytical School of Science. You should also have to follow us on our TikTok page, and even on our Facebook page as well as the Instagram. That's where you can have the full content on whatever we actually create, and which is good for you. And basically, in case you may need the detailed structure about the topics to be covered, just have to go through my video playlist on these actually pages that I've specified. You come across all these things. Thank you. Now on the mechanics, mechanics is the branch of physics that deals with that looks at the motion of the objects. So mechanics is the branches of physics, is the branch of physics that studies about the motion of the objects. That's what you get as the mechanics. And on the mechanics, we'll be looking at what you get as the linear motion. You should be well conversant with linear motion, and there are some other concepts behind. So we'll be looking at what you get as the linear motion, and on the linear motion, a big part of it will be looking at what you get as the equations of kinematics. These actually equations plays a major role. Equations of kinematics, and of course the other part of it will be looking at what you call as the applications of. We'll be looking at what we call them as the applications of linear motion, where I'll be looking at the two objects going towards each other, sort of, and I'll be looking at the two objects, chasing. So in case you may need the detailed structure about these applications, I just have to go through my video playlist to come across all this. And where I'll also be looking at the two objects starting from some position, and I'll be able to analyze what's all about. So that's about the applications of the linear kinematics we can have to discuss. And of course, on the same linear motion, we'll be looking at what we call as the free fall motion. So you should be well in line with free fall motion. You should be well understand about free fall motion. We'll be looking at the few parts of the free fall motion. That should be the way out. And we'll be looking at what we call as the projectile motion. We'll also have to cover some parts about the projectile motion, where we'll be looking at the different cases about the projectile motion, just the part of it. And finally, we'll be looking at what we call as the relative motion. We'll be looking at what we call as the relative motion, if at all we manage to have that. But in case, because of the time space, we want to finish actually relative motion, as a part of it, you just have to go through my video playlist to come across the relative motion, where I also probably explained the detailed structure about the relative motion. But hopefully, these are things that we should have to cover in our reviews. So in linear motion, that is linear kinematics. If we say kinematics is the study of the motion of the objects, so linear motion, it is the movement of object in one dimension. That is what we call as linear motion. In linear motion we have the parameters like time, we have the parameters like time. A time basically will be given in meters, that should be seconds. And we have the parameters like distance, and basically distance will be given, we'll be using distance, time as seconds, and the distance will be used as distance, should be d, or sometimes will be actually using distance as s. And we have the concept of the speed. On the speed, basically we'll be using meters per second, and it should be that. And we also have what we call as the displacement. Of course, displacement is the same as the distance, only that the displacement is having the speed as well as the direction. So displacement also bears the same units as that of the distance. I should say we'll use the same, and in some cases we can use the displacement as d, and in some cases we'll be using displacement as s. So, and also we'll be talking about the velocity as well. So on the case of the velocity, it will be the same as the speed, but only that the velocity, it will be the speed with direction. It will be given in meters per second. And you have the acceleration, and basically acceleration is meters per second square. And we have the deceleration, which is also said to be retardation. Deceleration, or to say it as retardation. And this one is the negative acceleration, and basically it is also being given meters per second square. So these are the things that you should have to understand about in that way. Let's say an object has moved from, let's say this is a point A, and it traveled all the way around, let's say, to point B. And let's say point A and to point B, the object, the 2 points are about 20 meters. And let's say that it has traveled in 2 seconds. So what can you say about the distance? Now, if we say a distance is the total length of the journey, and of which the distance will be given as 20 meters, it should be that. And what can you say about the speed, average speed? Now the speed of the journey will be given as 20 meters divided by the time. Mind you, a speed is given as the distance divided by time. That will be given as 10 meters per second. That is the speed. And what can you say about the displacement? So displacement, which we'll call it as s, corresponds to the difference between the final position as well as the initial position. And for this case, this is the initial position, and this is the final position. And basically, initial position, it is given as L, and the final position for this case, it is given as the 20 meters. If that is the case, then we have 20 meters and minus cell, of which the displacement will be given as 20 meters. And what can, in 20 meters to the right, because the final position, it is to the right. So it is 20 meters to the right, since the displacement is the distance with the direction. And what can you say about the velocity? So a velocity, it is a displacement, is the rate of change of displacement per unit time. So displacement is equal, I should say velocity is equal to displacement over time. That will be given as 20 meters divided by 2. That will be given as 10 meters per second, and to the right, since the velocity is the speed with the direction. Let's say we have this case. I want you to understand about the actual terminologies, and that because some of you tend to misunderstand these terminologies, you should have to get. Let's say the object has moved from A and let's say to point B, and say from A to B it is about, let's say, 30 meters, and after some time the object has traveled back. Let's say this is should be a point C. Let's say it has moved back, should be, let's say the object has moved back with about, let's say, 10 meters. So what can you say, let's say, should be in also 2 seconds as well? Should be that. Now what can you say about actually the distance of the journey? Now on the case of the distance, we should have to look at the total length of the journey. From A to B, that is 30. That is 30 meters. And from B to C, that is 10 meters. Therefore, the overall distance is 40 meters. And how about the average speed? Now the average speed is distance over time, that is 40 meters divided by 2 seconds. That would be given as, it should be 20 meters per second. 20 meters per second, that is the speed. And what can you say about the displacement? Now the displacement, we just have to focus on, the initial position and its final position. You should have that one. So what is the difference between the 2 points? You should have to get. That's what you get as the displacement. Now for that case, what is this final position? If you subtract actually a 10 from 30, this position, it is the position of 20. So final position is 20, and the initial position is 0. Therefore, you should have to expect that the displacement will be given as 20 meters. It should be 20 meters and to the right. 20 meters to the right. And how about actually velocity? Velocity will be given as 20 meters divided by the time takes, which is 2 seconds. That will be given as now 10 meters per second to the right as well. That is what you get as the velocity. And how about, let's say, if we have this case, you should have to understand. Let's say if we have the object traveled from A, let's say about 30 meters to B, and after some time the object got back to the same position, and let's say that is the case. So what can you say about, let's say in 2 seconds or so, what can you say about the distance traveled? Now the distance will be given as 60 meters. And how about the average speed? Speed will be given as 60 meters divided by 2, that is 30 meters per second. And what can you say about the displacement? Displacement is equal to 0, since the final position is the same as the initial position. And how about the velocity? Velocity is also equal to 0 because the displacement is equal to 0. So in all cases, actually, you can see that it is possible for an object which is rather, in all cases, you should have to understand that the object is said to have the 0 displacement when it has got back to the same original position, and the object is said to be having the 0 velocity when the displacement is 0, and also object is said to have the 0 speed when there is no distance covered. So keep that in mind. So let us see how we can analyze the motion of the object, specifically using the equations of kinematics. One thing you should have to understand is that acceleration is equal to final velocity minus initial velocity divided by t. That's why we say acceleration is the average rate of change of velocity per unit time. That is acceleration. Now for this case, this is the final velocity, this is the initial velocity, and this is the time it takes. That is how you should have it. So whenever an object is moving fast, it means initial velocity is less than the final velocity. Hence acceleration usually it is a positive. But whenever an object is moving, let's say slow, it means final velocity is less than the initial velocity, and basically acceleration becomes negative. That is now deceleration. So wherever you see the word deceleration, that corresponds to the negative acceleration, because the object is reducing speed. In other words, the object is coming to rest, or the brakes are being actually upright. Now let's say we have an object. Let's say it is moving towards this direction from point A with the initial velocity given as u. Let's say to point B with the final velocity given as v. And let's say the time takes is given as t. And let's say the distance from A to B is given as s as a displacement. And also the fact that the object is moving from A to B where the velocity is changing, then the object is said to be accelerating. So what are the equations that have been used to analyze the motion of the object, assuming that the acceleration is constant in all cases? If the acceleration of the object is constant, for the whole entire journey, then the following equations of kinematics are being used. Mind you, constant acceleration is the same as the uniform acceleration. If we say constant acceleration, it means at each and every point there is equal rate of change of velocity per unit time. That is a constant acceleration. Now the equations are such that we have the first equation, which is given as acceleration is equal to v minus u over t. And we have the another equation for the average velocity or average speed, which is initial velocity plus final velocity divided by 2. And we have the another equation, which is the average displacement is equal to u plus v divided by 2 times the time takes. And we have the another equation, which is displacement is equal to ut plus half area square. And we also have another equation, which is that of the v square is equal to u square plus 2as. These are equations of kinematics used whenever an object is moving at constant speed. Mind you, this is initial velocity, time takes, displacement, and the final velocity. And the acceleration, it is towards the same direction. So keep that in mind. Let us see how we can make use of these actual equations of kinematics in a typical equations. But before we go in the actual equations, I want you to understand about the acceleration in this way. Acceleration is given as the final velocity minus initial divided by t. Now, if the object is said to be having zero acceleration, should we say having the zero acceleration, it means the object is not moving? Let's try to say this. If acceleration is zero, it means we have v minus u over t. If we multiply t both sides, we'll have it as v minus u is equal to 0. So in this case, this is the same as v is equal to u. What is the information you can see from here? It means when acceleration is 0, it means the final velocity is the same as the initial velocity. So what is the final velocity being the same as the initial velocity? It means the object is moving at a constant speed. So whenever an object is moving at a constant speed or velocity, it means the acceleration is 0. So you can have the question, when do you expect that the object, when do you expect the object to have the 0 acceleration? So it is when the object is moving at a constant speed. You can also have the question, should we say an object having 0 acceleration is not moving? You'd say no, it is moving because it is moving at a constant speed. The fact that the object moving at constant the fact that the object moving at constant speed corresponds to have the zero acceleration. So that's how you should have it. Let's say we have this typical question. A car initially traveling at, so that is the initial velocity, that is 30 kilometers per hour, of which you should have to convert this in meters per second, in the sense that you should have to convert 30 kilometers in meters, that is the same as 30,000 meters, and you should also have to convert 1 hour to seconds, that corresponds to 3,600 seconds. Then you should divide the two, that is 30,000 meters divided by 3,600 seconds. So that's how you should have it. So we have there as initial velocity, which is that one, and the accelerator, the constant rate of, we have the acceleration, which is given as 1.50 meters per second square. How far will the car travel in 15 seconds? So how far corresponds to the distance or the displacement in 15 seconds? So we are looking for the displacement in the time of 15 seconds. So on the equations of kinematics, which equation satisfies the given parameters and what we are being entitled to have? And basically it is the displacement formula, which is ut plus half area square. So make sure that you are able to identify all the given parameters and you are able to interpret them, what they mean. So what if we have this question? A girl who is initially learning at, we have the initial velocity 1 meter per second, increases the velocity to, that is the final velocity, 2.5 meters per second, and we have the time takes, that is 5 seconds. So we should have the acceleration. What is that? So formula for acceleration, v minus u over t. You have the acceleration. And how about if we are to have even the displacement? How do you think we can have the displacement there? How do you think the displacement can be obtained if that is the case? So try to have it. Let's say this is the question. An airplane travels 40 meters, that is should be sort of displacement, should be 450 meters, and at a constant acceleration. Now if it starts from rest, that is initial velocity itself automatically, and we have the time takes, that is 15 seconds. So we should have a concept of the final velocity. How should you have the final velocity there if that is the case? So we have should be that of the displacement, initial velocity, and how should you have the final velocity? So we can use and there's no acceleration here, and of course what you can have is we can think of, let's say, using the equation displacement is equal to ut plus half area square, where we have the displacement, the initial velocity, time, we can find the acceleration. Upon having the acceleration, we can use the acceleration formula to have the final velocity. So that one. Now let us see how we can apply the equations of kinematics in some cases. Now our interest much will be using the actual displacement formula, that is ut plus, should be ut plus half area square, should be that one. Now whenever an object is said to be moving from rest, it means the initial velocity is 0. If that is the case, the displacement formula will be given as half area square, because the whole of this one will be 0. If the object is moving at a constant speed, it means the acceleration is 0. Displacement formula will be given as ut r will be given as vt, since if the object is moving at constant speed, initial velocity is the same as the final velocity. And basically you will see that this is the equation that will be used. Instead of using u, we'll be using v, because the final velocity, initial velocity is the same as the final velocity. So in all cases, if the acceleration is L, it means the object is moving at a constant speed. Therefore, displacement formula will be given as Vt. You should keep this in mind in case you tend to wonder what's going up there, but that's how you should have it. Now, on the applications, we'll have to understand about what we call it as the racing case, or we call it as the chasing. Racing or chasing. It should be not racing, chasing, but should be, we call it as, should be chasing, we call it as the chasing, or we call it as the raking, where one object is behind the other in that chasing, that one. Now let's see how we can analyze that one. Let's say we have, this is our object, let's say it is the object 1, and it is moving towards this direction, and say it is moving from rest with the initial velocity given as u, and let's say it is having the constant acceleration of, let's say, 4 meters per second square, and ahead of it there is another object which is moving towards this direction, and this object has to catch or overtake the other object ahead. Let's say this is object 2, and say it is moving at a constant speed of, I should have it as, let's say, 8 meters per second, since it is a constant speed. And let's say object 1 is behind object 2 about, let's say, 100 meters. After how long would you expect object 1 to catch object 2, and how far should it travel if that is the case, and what would be its speed for object 1 as it will catch the object 2? Those are the typical questions you should have to expect on the applications. That is racing case. This is the racing case, or call it as the lagging. Lagging means one is behind the other. Now, using the displacement formula that we already put it for, that displacement is equal to ut plus half area square. Now, since object 1 is moving from rest, displacement s1 for object 1 will be given as, now the whole of this one is L, we'll only substitute acceleration here, that is 4, and 4 divided by 2, that is 2. We'll have it as 2d squared. That is equation 1. And also in the same case, you should have to understand that since it is moving at a constant speed, it means acceleration is L, therefore the displacement formula will be given as, s2 will be equal to, what is velocity? That is 8. We'll have it as 8t. That is equation 2. And now you should have to understand that in order for object 1 to overtake or catch object 2, first thing, it must cover the distance it is in behind with, and then second, it should have to cover the distance object 2 traveled when the object 1 was traveling 10 actual meters. If that is the case, then s1 is the same as 100 plus should be s2, because in order for object 1 to catch object 2, it must cover the distance it is behind with and the distance object 2 has traveled when the object 1 was covering that distance. So from there, we'll have to substitute. We'll have 2d squared is equal to 100, and that is plus, what is s2? We have it as, should be 80. So if that is the case, we'll have it as 2d squared minus 80t minus 100 is equal to 0, where we'll have to solve for t using the quadratic formula. By the way, this is the quadratic equation. We'll have to simplify that one. So in that case, we'll have t squared is actually minus 40 minus should be 50 is equal to 0. So how do you think we should have to solve that one? So we have to use quadratic formula. We need to solve that and using the quadratic formula, which is now t is equal negative 4, that is a positive 4 plus or minus square of what is b, we have 16, and the minus 4 should be what is the a, we have it as 1, and what is c, negative 50, and that divide by 2a, which is 2. That is, now we have it as 4 plus or minus the square of, now what is negative 4 times negative 50, that is 2, and we have 16 plus 200, which is divided by 2. So what is 16 plus 200? What we can have is 16 plus 200, we'll have it as 216. And what is it's actually square root, we have 14.7. So in this case we have a time being given as 4 plus or minus square of 14 point should be 7 divided by 2. Then you just have to select the value of the time which is positive. Therefore time will be given as 4 plus 14.7 divided by 2. Of which you have it as 9 seconds. So which means the time is given as 9 seconds. So object 1 has to travel about 9 seconds to catch or overtake object 2. And also object 2 also have to travel the same time, which is 9 seconds. And it is the same for all. And how can we have the distance traveled by object 1? So simply just have to substitute in that to have the distance traveled by object 1. And also in the same case, in order to have the speed at which it will overtake object 2 or catch object 2, since we have the initial velocity 0, acceleration is 4 meters per second square, the distance traveled, we'll have it upon substituting here, and we also have the time, which is 9 seconds. We can be able to have the final velocity as it will overtake the other there. That we can use the equations of kinematics. So keep that in mind. And what if, let's say, we should also have to understand about another case. But by the way, what if the one object is behind the other in terms of time? Let's say we have object 1 like that, with, let's say, initial velocity, let's say, given as 2 meters per second, and the acceleration is 3.5, should be 3 meters per second. Let's say that is the acceleration. And the object 2 is moving, let's say, initial velocity is given as, let's say, 2 meters per second as well, but acceleration is, let's say, 2 meters per second square. And let's say object 1 is behind about 10 seconds. How do you think you can have that? Of course, the principle remains the same. Using the displacement equation, it means the distance for object 1 will be given as 2d plus 1.5 d square upon substituting. That is equation 1. And how about S2? We'll have it as 2d as well plus d square. That is equation 2. But now, unlike with the previous case where we had one object behind the other in terms of the distance, but now we are having the separation in terms of the time. But in all cases, our analysis is done by using the separation as a distance. But now we have time. How should we have it? So you come on the other point where you say separation distance. Separation distance given as SD. You say separation distance given as SD. SD will be given as, now you substitute 10 seconds into the displacement equation for object 2. Mind you, what you are to calculate is not S2. you are calculating separation distance within of actually corresponding to 10 seconds. And mind you, this distance actually this time has been covered by object 2. So no wonder we are to substitute this time into the displacement formula for object 2. So for that case, you have it as 2 times 10 seconds plus 10 seconds to the power 2. That corresponds to have it as SD being equal to 20 plus 100. So that is 120 meters. So which means here, instead of having 10 seconds, the distance corresponding to the 10 seconds is 120 meters. So which means from here you can have the way we have done it before. So that is. So in all cases, if you have been given the separation distance, if you have been given the separation parameter or the chasing parameter as a time, you just have to substitute that time into the distance equation for the object on the ahead. That will give you the distance corresponding to that time. Then you solve it the way we have done it before. So don't confuse things. Whatever you calculate here, it is not the same as S2. You'll be calculating the separation distance. That is. And let's appreciate another case of, you should have to understand as well. What is that one? Head-on case. On the head-on, that's where the two objects are going towards one another. Let's say we have this is object 1 moving towards the direction. Let's say from rest, initial velocity is L, acceleration 80 meters per second square. And we have object 2 moving towards this opposite direction, with initial velocity 2 meters per second. Acceleration, let me call it as 6 meters per second square. And let's say the two objects are away from each other about 20 meters. So what do you think will be the time in which both will meet at somewhere? And how long shall they actually travel in order to meet at the center or somewhere? And now for this case, we'd like to look at how far the object 1 has to travel in order to meet object 2, or object 2, how far should it travel, and after how long as well. That's the point of interest. But using the displacement formula, we still more have the courage that the object 1, the displacement is given as should be 4 actually t square, and that is equation 1. And how about the S2? We can have it as 2t plus 3t square. That is equation 2. But in all cases, assuming that no object, assuming that the objects are to meet within the separation distance. So no matter what, the distance object 1 has to travel, distance object 2 has to travel, should not exceed 20 but should be equal to 20. That's how you should have understanding. So if that is the case, then you have to substitute what is S2. S1 is given as 4d square. And how about the S2? We have it as 2d plus 3d square, which is equal to 0. So from here, having the like terms together, we can have it is equal, should be not equal to, but should be equal to 20. Should be that. Now we have it as being something about, we have it as 7t square and plus 2t minus 20, which is equal to 0. Now we can solve for t using the quadratic formula, the way we have done it before. And from there, upon having t, we'll substitute to have the distance for S1, also substitute to have the distance for S2. And you can also have, by the way, that time corresponds to the time both has to travel. And I can also have the distance traveled upon substituting this. And also even to have the velocity of whatever the object as they will meet somewhere. So that's how you start to understand about the chasing should be the head-on case. Now let's finish with on the application by looking at the racing case. The racing case, that's when the objects are starting moving from the same position and start moving. So that is what is called as the racing case. Let's say this is the object 1 and this is, let's say, object 2. And let's say object 1 is all the way from rest, initial velocity, acceleration, let's say 4 meters per second square. And let's say object 2 is let's say the object 2 is also from rest as well, and say acceleration and has to be somewhat about, let's say, given as 8 meters per second square. Now, where do you expect object 1 to overtake object 2, or object 2 to overtake object 1, or the objects to overtake each other, and after how long? So that's the point of interest. But now, using the displacement equations, S1 will be given as 2d square. That is equation 1. And also on the same case, S2 will be given as 4d square. That is equation 2. You should have to understand that since the both objects, started moving from the same position, and even up to where the two objects will overtake each other, they'll have to travel the same distance. Therefore, S1 is equal to S2, of which we have it as, 2d square is equal to 4d square. That will have it as 2d square minus 4d square is equal to 0. And by the way, we should have, a one object moving at a constant speed. We should have the one object, let's say it should not be that, but one object should have the initial acceleration there for it to work. Let's say initial velocity for object 2 is given as 2 meters per second. It means the displacement for object 2 has to be S2 is equal to 2d plus 4d square, of which we can have it as somewhere about 2d square, and is equal to 2d plus 4d square. That will have it as 2d square minus 4d square minus 2d is equal to 0. So now what we have there is negative 2d square minus 2d is equal to 0. We should have to factor out it. We'll have it as negative 2d, that is, now we have d plus it should be 1, which is equal to 0, and of which we have, we just have to solve for the positive value of d. But of course, it is just unfortunate that if we have d plus 1 is equal to 0, and for this d, for this case, still be negative, but of which d can't be positive. But now, assuming that the d was a positive value as 1, then it means both objects has to travel about 1 second before they overtake each other. Then the distance traveled can also be obtained upon substituting d in this. And you observe that the distance traveled could be the same for S1 as well as S2 upon substituting. And also in the same case, you can also be able to have the speed in which they'll have as they will overtake each other. But that's the point of interest. How about, let's say, if we have this other case, let's say we have this is object, let's say 1 moving at a constant speed of 12 meters per second, and the object 2 moving from rest, initial velocity 5 meters per second, should be, let's say, 2 meters per second, and say acceleration is given as 8 meters per second square. When will the two overtake each other, and after how long? So principle remains the same. S1 12d, that is equation 1. S2, that is 2d plus 4d squared, that is equation 2, like that. Then S1 is the same as S2. That is 12d is equal to 2d plus, it should be 4d squared. That we can have it as negative 4d squared, and that should be plus 12d. By the way, this and that will be given as plus 10d, that will be equal to 0. Then from there we should just have to factor out, and that should be actually 2d, that will be given as negative d, and plus 5, which is equal to 0. Therefore, just have to concentrate on the positive value of d. That will be given as negative d plus 5 is equal to 0. Then d will be given as 5 seconds. So this is the time both has to travel before they overtake each other. Then you can be able to have the distance traveled by object 1 or 2, and since the distance will be the same, and even the speed in which the object 2 have as it overtake the object 1, that is the final speed. Since this is initial acceleration times object x, then if you have the displacement, the speed will be able to obtain using whichever the equation of kinematics. So please keep that in mind. So let's have some questions related to whatever I talked about here in the little case of the problems. And now let's say this is the question: two cars doing actually 240 meters apart. Actually it should be two cars 240 meters apart, head straight for each other. So which means the cars are moving like this. This is, you can say, car 1, and we have a car 2 somewhere. Should be given as the car 2, and they are moving towards each other, and the separation distance is actually 240 meters. And I should say this is, they are calling it as, this is a car A. Let me use that. This is a car A, and this is car B. Sometimes you can actually notify them on your own based on the way they have been given, and both are moving at a constant speed, and also this one is also moving at a constant speed of, should be 40 meters per second. How long until they meet? We are talking about should be the time takes for them to meet somewhere. So principle remains the same. What is the displacement for car 1? That it should be car A, that is 10d, that is equation 1. And displacement for car B, that is 14d, that is equation 2. Then from there we should have to understand that SA plus SB has to be equal to, should be 240. Should be equal to 240. Then what is SA? We have it as 10d and plus 14d, that is equal to 240. It should be given as 24d, which is equal to 240. And for this case, the time will be given as should be that of the 10 seconds. So which means both has to travel until they meet about 10 seconds, and the distance traveled by each just have to substitute, and S after SB as well as the SA. And now let's say this is the question: two runners start with 500 meters apart on a straight track and land towards each other. It means this is lane 1, and this is, we can say, lane 2, and the lane A starts at, that is initial velocity given as 5 meters per second, and by the way they are about 500 meters away from each other, and are having the acceleration of 0.5 meters per second square, and lane B is moving at a constant velocity of should be 6 meters per second. When and where do they meet? We're looking for the when corresponds to the time, and where, and it corresponds to the distance each has to travel. So as you can see it here, you can be able to have that one, and that is S1 corresponds to have it as 5d, and plus C should be acceleration 0.5. That corresponds to have it as should be, we know that we'll have it as, half 0.5, d square somewhere about, 0.5 corresponds to have it as should be half as well. That corresponds to have it as 5d plus 1 over 4 d square. You can have it as, actually you can have it in a, should be decimal, can be okay. That is S1 should be equation 1, and S2 corresponds to have it as 16. Then you used to have to understand that, S1 plus S2 is equal to 500, actually 500 meters. So you'll be able to have the time from this, and later as you substitute to have their corresponding should be distances they have to travel. So that is. And now let's say this is the question. Car A is 120 ahead of car B. So which means this is car B, and car A is ahead of car B about 120 meters. Should be that. And car A goes about at a constant speed of 15 meters per second. And the car B is also moving at a constant speed of 20 meters per second. How long for B to catch A? So principle remains the same. What is SB? That is 20t. That is equation 1. What is SA? We'll have it as 15t. That is equation 2. In this case, you should have to understand that the SB is equal to 120 meters plus SA. And from there, you'll be able to have the damped x, in the sense that we'll have it as should be 20t. We'll have it as 20t is equal to 120 plus 15t, of which we'll have it as 20t minus 15t is equal to 120. That will be given as should be about 5d is equal to 120. That you can be able to have the damped x. That is how long. And let's say this is a typical question as well. A bus leaves a stop with a speed of 10 meters per second. It means the bus is moving at a constant speed, and the car behind accelerates from rest. That is, so which means a car isn't behind, and the bus is somewhere ahead. So a bus is moving at a constant speed of 10 meters per second, and the car from rest, initial velocity as well, acceleration is 1.5, should be meters per second square. And if the car begins 20 seconds later, it means the car is behind the bus about 20 seconds. When and where the car catches the bus? When do you expect a car to catch the bus? And after how long? So this is a typical, actually, a chasing case. So for this case, using the displacement formula, SCC will be given as, half 1.5 should be half times 1.5 d square. You just have to divide that one, and that is equation 1. And SB will have it as 10t. That is equation 2. But we should have the distance corresponding to 10 seconds. Now we'll have it as the separation distance being equal to, we'll have to substitute 20 seconds in the displacement formula for object which is on ahead. We'll have it as that one. That will be given as 200 meters. So which means the car was in behind about 200 meters. Then from there you can have the way we are doing it. And now let's say this is the case. Two runners start together, and we have a runner A and we have a runner B. Should be that. And the runner A is moving at a constant speed of should be 6 meters per second. And the runner B starts from rest, initial velocity 0, and the acceleration 0.8 meters per second square. When does B overtake A? In other words, when do you expect B to overtake actually A? Or when do you expect the two objects to overtake each other? We are looking for the time. This is a racing case since they start from the same point together. So using the displacement formula, what is SA? We have it as 60. That is equation 1. And what is SB? We can have it as, should be, 0.40 square. That is equation 2. Then you just have to understand that up to the point where the two will overtake each other, SA is equal to SB. That we can have it as, 60 is equal to 0.40 square. 60 minus 0.40 square will be equal to 0. Then I'll have to factor out the t. We'll have it as 6 minus 0.40, which is equal to 0. Then I'll just have to concentrate on that. We are solve for t. So that would be the term text. So even if we wish, you can also have, anyway, we'll have 6 minus 0.40 will be equal to 0. And what will be the t? We'll have it as, 6 divided by 0.4. That will have it in seconds with your calculator. So even if you wish, you can also have, the speed in which the object B will have to overtake object A with using the equation of the kinematics as well. So that's how you start to understand that one. And now let's say this is a question as well. From rest at the same point, object A, accelerates, should be from rest, initial velocity 0, acceleration 0.3 meters per second square. And the object B, also initial velocity 0 and the acceleration 0.6 meters per second square. Should be that. But object B has the initial backward velocity of, by the way, it means the object B is having actually initial velocity of -2 meters per second, like that. Now the question says, when do they have the same position? In other words, we should have to calculate the distance in which both have to travel before they overtake each other, using the principles behind the way I've been talking about. So try to have that. Now let's look at what we call as the free fall motion. Let's now concentrate on what we call that as a free fall motion. So a free fall motion, it is a movement of object that is it is the movement of object that is along actually y-axis. That is a free fall motion, and along y-axis object moves under the influence of gravitation force only, with negligible air resistance. So free fall motion, that's why the object is moving under the influence of gravitation force only, with negligible air resistance. So we have 4 cases you should have to consider about them in the free fall motion. We have what we call as the one way up, where the object is moving upwards, and we have what we call as the one way down, where the object is moving downwards, and we also have what we call as the symmetric motion, where the object is thrown upwards and back the same position or the same level. And we also have what we call as the top up ground, where the object is released from the top and to the ground, where this is the height of the throne. This is the height of the building where the object has been released from. So you should be well conversant with all these things actually to do with free fall motion. So we'll have different questions to do with all these cases of the free fall motion. Just have to pay attention. Now let's say this is a question. A passenger in abandoning a sinking ship steps over the side. The deck is actually 50 meters above the water surface. With what velocity does the passenger hit the water? So for this case, as you can see, it is about the object. It is about the object falling down. So should be that. It is about the object falling down. So that is one way down. So on the one way down, acceleration due to the gravity is positive. So it should be a positive. Whenever the object is moving downwards, acceleration is positive. And we have the height, which is 15 meters. Should be 15 meters, as you can see. The height is 15 meters. So we are looking for with the wide velocity, that is the final velocity. So it should be that. And basically, since the passenger actually seems to be just falling down with no any effort, and just from him or her, basically initial velocity is 0. There are two things you should have to understand about the one-way down motion. If the object has been thrown, being thrown, it means the initial velocity cannot be 0. It can be something else other than 0. But if the object has been dropped or being released, initial velocity is basically 0. But in this case, the passenger has just released him or herself. It means the initial velocity is 0. So which equation should we use to have that of interest? That is the final velocity. So we make use of the same equations of kinematics. And since we have the height, we have the acceleration, and we are looking for the final velocity with the initial velocity there, then we can use the, and that we can use is, should be that. We can also use v square is equal to u square, should be plus 2gh. We can use this one so that we can solve for the final velocity. Since initial 0, we have the height, acceleration due to the gravity, we can have that one. So it should be that. That is the formula to use. And let's say this is also the question: how long does it take for a stone to fall from the bridge to the water? So which means the object is also falling down. And since the stone is said to be 4, it means the initial velocity is 0, basically. And we have the height, which is 30 meters, should be that. And moving downwards, acceleration due to the gravity is 9.8 meters per second square. We are looking for the final speed or the velocity as it hits the ground. And we are also looking for the actually dampings for the object to reach the the level, to hit the water, that is. So we need to have the damp first. So which equation, since we have the initial velocity, we have the height and the acceleration. So the equation has to be the displacement equation. That we have it as the height is equal, ut plus half gd square. So we have the height, and we have the initial like that, and we can be able to have the dampings. So that is, and from there we can also have the final velocity, either from formula acceleration is equal to v u of t, should be that, and we can have the acceleration, actually final velocity there. So that is about the case where the object is falling downwards. So object falling down, acceleration due to the gravity is positive. And let's consider this kind of a scenario. A ball is thrown vertically upwards, so which means the object has been thrown up, and with initial velocity given as 40 meters per second. And since it is moving against the direction of the gravitational force, that is, now acceleration due to gravity is negative. So you should have that. And we are told to have the position and the velocity at the end of 2 seconds. So we need to have the height obtained when the time is 2 seconds. And we should also have the velocity at the same point. So in order to have the position as the object is moving upwards, we use the displacement formula, which is height is equal to ut. Now for this case, we'll have it as minus gt square. Now what you can have is we are looking for the height. We have the initial velocity, which is 40, and we have the time, that is 2 minus half acceleration due to gravity, sort of. Then a time 2 seconds square, we'll have the height. And we need to have the final velocity there. Final velocity is equal, negative gt plus u, where this is the time we have 2 seconds initial velocity, like that. And this is acceleration due to gravity. We can have that one, or else we can use this one. V square is equal to u square minus 2gh. So where this minus corresponds to the negative g. So you can have that one. So let's consider this kind of a case. A ball is thrown vertically upward from the top of a building 40 meters high. So this is now another case. We have the height of the building, which is 40 meters. And it has been thrown up, and it should go like that. So initial velocity is given as 25 meters per second. And now the question says that what is the total time that the ball is in the air? So for this case, we need to have the time takes for the ball to reach at the ground from the top of the building upon being released up. So how do you think we should have the time takes? So now the total time is calculated from the displacement formula, which is h is equal to ut minus half gt square. You should have to understand that this case of the actually free fall motion, it also uses the same as negative g. And now since we are looking for the total time, we have to create as total time corresponds to the capital letter T minus half g t total square. So we have the height of the building, which is 25. But now you should have to understand that from here and to the ground all over up, the displacement of the whole journey is given as the negative height of the building, because just cutting here, displacement here is the only displacement that would be covered, that would be considered from here up to here all over, it is the height of the building. That would be substituted as the negative. So half negative 40 meters is equal to the initial velocities should be 25 d minus half gt total. Then we'll have the time takes using what we call as the quadratic formula, or so for actually d. And you can also have the velocity as the object will be striking the ground, which is final velocity is equal to negative gt total plus initial, half that one. And even the overall height, what is the overall height from the ground to the maximum position? So mind you, velocity at the maximum position is said to be cell, which is said to be the Vmax. Velocity at the maximum position is given as cell. So in order to have the overall height, we need to have the height of this position, of which, if you look at this case, what we have up, that is a symmetric motion. So we should have the height according to the way we understand about the symmetric motion at this point. So in order to have the height from the top up to this point, we should have to use the formula, which is v square is equal to u square minus 2gh. I'll call it as should be, let me call it as the capital letter H, should be that, where v is the Vmax at the maximum position, which is its initial velocity at 5 to the power 2 minus 2 times acceleration due to gravity, and also for this. And upon having this, then this height plus the height of the building, you have the overall height. That is. And now let's say this is the case. A stone is thrown vertically upward, and from the bridge is 30 meters high. You know, it is the same case. So should be that. And this is the height of the bridge. I'll call it as the edge. That is should be 30 meters. And the initial velocity of the thrown is 15 meters per second. Now we are looking for the time takes for it to reach the ground. So principle remains the same, the way we have talked about it, that one. And I also try to have the overall height and also the velocity as it strikes the ground, which is the final velocity. And now let's say this is a typical question. Suppose the baseball is thrown straight upward with an initial velocity of, now in this case the object has been thrown straight up. The object has been thrown straight up, sort of, and with the initial velocity given us should be u, which is 30 meters per second. And for this case, acceleration due to the gravity is negative. That much we already know. Negative should be that square. Now the first question says find the maximum height of the ball. You know, as the ball has been thrown straight upwards, it reaches a point where it will not go further. At that point, we call it as the maximum point, where the velocity there, it's 0, that is the final velocity, we call it as the Vmax. So how should you have the, you know, that of the height it attained, that is Hmax, which is the maximum height. So we use the equation which is v square is equal to u square minus 2gh, also for height, where this is the final velocity at the maximum position is 0, we have the initial velocity properly. And another part of the question says which to find the time it takes for the ball to rise to the top of its motion. We need to have the time it takes to reach at this point, and of which we call it as the Tmax. The time it takes to reach at the top, what is that one as Tmax? And how do we find that one? We use the formula final velocity negative g. Now we're looking for Tmax and plus initial velocity. So we are looking for the Tmax. So final velocity, which is Vmax, is equal to negative g Tmax plus initial velocity. We'll have that one. And the question part C says which to find the time takes that the ball is in the air. Now we assume that the object is now back to the original level. We need to have the time for the whole entire journey. So this case of the freeform motion, it is said to be the symmetric motion, or ground up back to ground. So where we should have understand that for this case of the actually a freeform motion, the time for the whole entire journey is the same as 2 Tmax. The time to raise the time to reach at the top, it is the same time the object will get back to the ground. In other words, we have the one way up and one way down. So it should be that. So the time to reach at the top, it is the same time it will get back to the ground. So that is how we should have the total time for the whole entire journey. And apart from that one, the total time can also be obtained using the equation final velocity is equal to negative gd total plus initial. If we have the velocity as the object strikes the ground, if we have the initial velocity, we can be able to have the total time. We can also use that formula, much as we have the final velocity. And the question D says, which to find the velocity of the ball as it strikes the ground. Now we're looking for the final velocity. Since we have the d total and the initial velocity, we can be able to have the final velocity at that point. And we should have the position and the velocity of the ball as at 4 seconds. So we already talked about how we can have the position and the velocity as the object is moving up. Try to refer to that one. And that is, I said, the position we use the height is equal to ud minus half gt square, where we have the time initial velocity we have, we'll be able to have the height. And the velocity there will be given as, negative gt plus u, that is initial velocity. The term takes will have the velocity there. So that is. Now let's extend our reviews by looking at the projectile motion. So projectile motion, it is where the object is moving in 2 dimensions. We call it as a projectile motion, or we call it as 2D kinematics. So in a projectile motion, you should be well conversant with the following cases. We have what we call as the ground up back to ground. The cases are the same as that in the freeform motion, but now we're talking about the moving in a 2 dimension. So this is the ground up back to ground. So where the object is released from the ground at an angle theta, which is the launch angle, with the initial velocity v0, which is the launch velocity, and the moving up and back to the same ground. As it will be striking the ground, the object will have 2 components of the velocities. We'll have the final velocity which along x, which is vfx, and we'll have the final velocity on y, which is vfy. And we can have to find the magnitude of the landing speed, since we have the 2 components of the velocities. Much as we know the vectors, we can have the magnitude of the landing speed, which is given as the magnitude being given as vfx square and plus vfy square. And how about the direction of the landing? We'll have it as theta is equal to the tan inverse of vfy divided by vfy actually x. Vfy corresponds to the a final speed or the velocity along y-axis as the object is striking the ground. You should keep that in mind. And also you should have to understand that as the object is to move, this is the launch position. It will have the initial velocity along x that we call it as v0x. That is the initial velocity. That is being calculated upon resolving the initial velocity into components. That is v cos theta. We should have that on v0 cos theta. So v0 cos theta. That is the initial velocity along x. And we have v0 sin theta, initial velocity along y. And the object reaches at the maximum position, where mostly final velocity Vmax is 0, unless otherwise. We can be told that it is not 0, but unless otherwise. And at this point, acceleration due to the gravity, its stromal should be 9.81 meters per second, although velocity is 0 there. And the height to move from this point to this point, we call it as the Hmax. So this is Hmax. So in the distance along x from the launch position to where the object strikes the ground, we call it as the horizontal distance, and we also call it as the length. So keep that in mind. So these are some of the facts you should have to understand about this case of the projectile motion, which is said to be the symmetric motion or ground up back to ground. And for the sake of interest, the formula for the maximum height, it is given as v0 square sin square theta divided by 2g. And the formula for the length will be used. We'll call it as, v0 square, sin 2 theta divided by g. And keep in mind that sin 2 theta, it is the same as 2 times sin theta and cos theta. And if you want the detailed structure about this case of the projectile motion, just have to refer to my video prior to come across these things. And basically, that's the horizontal distance, which is the length. But also the horizontal distance, which is the length, is also being given as, v0 cos theta times the total time. And by the way, along x-axis, acceleration due to the gravity is 0, because the gravitational force is not felt. Therefore, initial velocity along x is the same as the final velocity along x. So those are some of the things you have to understand about this case of the projectile motion. Let's appreciate some few questions about this, then you should have to move forward. And now the question says that a ball is thrown with initial velocity of 30 meters per second at an angle of 60 degrees, and it should be above the horizon. And now we have the launch velocity, that is 30 meters per second, and we have the launch angle, which is 60 meters, should be 60 degrees rather, should be that. And the first question says we should have the maximum height of the ball. And by the way, this is a typical, actually a symmetric motion, or we call it as the ground up back to ground. And the formula for the maximum height is given as should be v naught square sin square theta divided by 2g. That is, of which v naught, that is the launch velocity, that is 30 meters to the power 2 sine 60 and overall to the power 2 and divided by 2 times acceleration due to the gravity. Should be times acceleration due to the gravity. Just have it as that one. And the overall units has to be in meters. So with your calculator you have that one. And you can think of having the sketch of the case of the projectile motion, and really it helps us all. In physics, much of it requires you to come up with a sketch of the concept you are analyzing. So in this case, you should have, by the way, we have, I saw something like this. We have the object being released like that, and back to the ground. So this is the launch angle, that is 60, and the launch velocity, which is 30, like that. And this is the maximum height we have solved for, should be that. And the question B says that the damp lies to the top of the trajectory. So we need to have the damp it takes to reach at the top. That is a Tmax. So Tmax is calculated from the formula final velocity negative g Tmax plus initial velocity. But now this initial velocity, it is along y-axis. So that will be given as should be v naught sin theta, that is the initial velocity along y. And acceleration due to the gravity is negative, and this is the Vmax, velocity at the maximum position. And upon making Tmax as a subject, we'll have it as Tmax is equal to v naught sin theta divided by g, of which this negative has already been gone upon making actually a Tmax as a subject. We just now have to simply substitute 30 times sin 60 divided by 9.81, then we'll have it in seconds. So that is. And how about the question part C? Now the question part C says that we should have the total time the ball is in the air. Now the time to move from here up to here, that is the t total. So t total is the same as 2 times Tmax. The same way we discussed about it in a freeform motion, it is the same way here, because this motion, it is the symmetric motion. So which means if we have the t total, we can also have the Tmax as well in that way. And the D says we should have the range. What is the formula for range? Range is given as v naught square sin 2 theta of should be g. That is the range. In the basic array, we can also have the range being given as v naught cos theta times the t total. We can also have it in the same way like that. And the question part E says that we should have the velocity of actually a ball as it strikes the ground. So what is that one? So we are looking for the landing speed as well as the direction. So mind you, as the object will be falling down, it will be striking the ground, it will have the final velocity actually along x as well as the along y. Now initial velocity along x, it is the same as the final velocity along x, because acceleration on x is equal to 0. So have it as that one. And how do you find the final velocity along y? We have it as final velocity along y is equal to negative g times t dot plus initial velocity along y. This is the formula. You can substitute and find vfy. That would be negative, of course. Then using, we need to have the landing speed, which is now landing speed is given as, square root of, vfx square plus vy square, and the direction, which is this angle, we'll have it as the tan inverse of, vfy over vfx. So that's how you start to understand about that. So now let's consider this kind of equation. A shell is fired from a cannon at a velocity of 300 meters per second to hit a target of 3,000 meters away. Now what you have to understand is that now at what angle above the horizontal should the cannon be aimed at? So this is a typical ground up. This is a typical ground up back to ground. That is a symmetric. Now a shell has been fired with at an angle of theta. We don't know, but the launch velocity is given as 300 meters per second, and it is being aimed at having a target of hitting a target of 3,000 meters away. So from here up to here, that is now we're talking about the range. So which means the range that is given as 3,000 meters. Now the question says we should have the angle theta. We use the formula for range at that point, of which the range is given as, the range is given as, v naught square sin 2 theta divided by, should be somewhere about, that should be g. That is the formula for actually a range. So we have the range being given as 3,000, initial velocity 300 to the power 2 sin 2 theta, and I divide by g. To know that, we can play it as, should be somewhere about, let's have the typical calculations there. But by the way, just have to calculate the angle theta, that on your own. But you should have to understand that, having sin 2 theta, this is the same as having it as 2 sin theta cos theta. So just have to play it as, in fact, I'm away from my calculator, so I have it as 3,000, let's say 300 to the power 2, let's say half that one. Now we have it as the same as 2 sin theta cos theta divided by g. Now for that case, you just have to try to work it out with a calculator. You have it. And also on some cases, using the same case of the projectile motion, we may have, let's say, given that the range of the projectile motion is, let's say, 2 times the height it reaches, find the value of the actual launch angle. So now the range is given as v naught sin 2 theta divided by g, and the height is given as v naught, actually v naught square there, v naught square sin square theta over 2g, and for this case this and this will cancel. And what is sin 2 theta is the same as 2 theta cos theta over g, which is equal to g, and g also cancel as well. And what you can have is something about, and what you can have is something about, you can also have to cancel this, also be able to cancel as well. Now what is sin theta, another sin theta, because we have sin square theta there. And what you can have is sin theta also have to cancel, and even the g's also have to cancel. We don't need to have g here, that one. So for that case, we can have it as, should be cos theta, which is equal to somewhere about, we should have 2 cos theta is equal to Tan theta there. And what you can have about is we should have to divide the two so that we should have tan. So for that case, we'll have to divide both sides by sine. Should be cos rather. We'll have 2 is equal sin theta over cos theta. That is 2 is equal to sin, is now 2 is equal to tan theta there. So have it as tan theta. You'll be able to have the value of the angle theta there. And what if the height is 3 times the length? Try to have the angle. What if, let's say, the length is half the height? Try to have that one. But now, what if the length is, let's say, 5 times the height? How do you think we can have that one? Now, let's say this is a question. A golf ball is hit with an initial velocity of that one at an angle for this above the horizontal. That is a typical case where we can have it as that, and it has been actually hit. And that is, we have the launch velocity, which is given as 50 meters per second, and the launch angle is given as 55 degrees above that. It should be that. Now the question says we should have the how high would the ball go? Within the maximum height, that much you know. What is the total time the ball is in the air? We are looking for the d dot, which is 2 times t max. You should have to calculate what is t max for this case, and how far would the ball travel horizontally. We are looking for the length. That much length v naught square sin 2 theta over g. You can have that. In another case of the projectile motion, we call it as the top horizontal released ground case, where the object is released from the top and horizontal to the ground. This is another case of the projectile motion, where the object will strike the ground with 2 components of the velocities along x as well as along y, and this is the horizontal distance, which is given as hg, which is also given as the length. But the way we calculate the length will not be using the same way we discussed. The length will be strictly horizontal distance as the length will be strictly being calculated as, launch velocity times the d dot. And the launch velocity here is given as that, and which is the same velocity as the object will be striking the ground. In other words, initial velocity along x is the same as the launch velocity along x, which is also the same as the final velocity along x as the object will be striking the ground. And the velocity along y initial is zero because the object is horizontally released. And let's say this is the height of the building. You should have understand. So how do you find the total time for the whole entire journey as the object is to move from here up to here? Now a total time is calculated as the height of the building, minus g total time plus the initial velocity along y, which is v naught y, which is basically 0. Therefore the height of the building is equal to negative g d dot. This is the formula we can use to have the total time in case we have the height of the building. And basically when you're substituting the height of the building, it's negative, so have the negative as we'll be substituting that one. And also in the same case, acceleration to the curve is negative. And apart from that one, we can also have the horizontal distance, which is given as the launch velocity times the total time. And how about the velocity as the object is striking the ground along x? It should be along y. We use the formula vfy is equal to negative gd dot and plus the initial velocity along y, which is given as 0. No, we can have it as that. We use that one as that. So this is the formula we use to have the final velocity along y as the object is striking the ground. And by the way, let me take it back here. Height of the building is rated as ud dot minus half gd square, not that one. And I'm sorry for that. but that is, so in this case the initial velocity along y is said to be v naught y d dot, but basically it's 0. Then the height of the building is given as negative g d dot square. So when substituting actually h, you have it as a negative, also for actually a d dot. If we have the h, we can also behave, okay, if we have the d dot, we can also have the maximum height. So it should be the height of the building using the same formula. So let's appreciate some questions related to this and then be able to have the knowledge about. And now let's consider this kind of a case which says that a projectile is thrown from the top of the building with the horizontal velocity. Horizontal, that corresponds to the object, that is, it corresponds to the top horizontal released ground case, where the object is released from the ground horizontal. It should be from the top horizontal, and it should be that. So a v naught, which is the launch velocity, is given as 15 meters per second, and the projectile lands on the street 85 meters away from the base of the building. That is now the horizontal distance, which is hd. 85 meters per, actually should be meters. Now the question says that how high is the building? We should have the height of the building, as we have already actually talked about. The height of the building, which is h, is given as negative half g d dot square, because from the displacement formula, height is equal to ud minus half gd square. By the way, this is for d dot, but since initial velocity along y is 0, it means we'll have the whole of this one 0. We'll just have to remain with that one. So keep that in mind. So from there, what you can have is just have to substitute it. And basically height is equal. Now what we are working is the d dot. We cannot be able to have the height without the d dot. So which means we should have the d dot first. From horizontal distance is equal to the launch velocity times d dot. What is the horizontal distance? We have it as 85. What is the launch velocity? 15 times d dot. We'll have the d dot, we'll put it here, we'll have the height of the building. And on the same case, we can also have the velocity as the object is striking the ground. So as the object will be striking the ground, it will have the two components of the velocities. Stream will have v for x, which is the same as v for x is equal to the launch velocity, which is 15. And how about the vfy? That is vfy. We already talked about it, that being given as negative gd dot. So since we have the total time, we'll substitute half the vfy. Then we're looking for the landing speed. We have it as landing speed being given as the square root of vfx square plus vfy square. And the direction, which is this, we also have it as tan theta is equal to vfy of vfx. We'll have it as that. And also let's consider this kind of a case. A cannon is placed on a hill 20 meters above the level ground. So let's say this is a typical hill whose height is 20 meters, and the shell is fired horizontally. That is the horizontal. The launch velocity v naught is equal to 300 meters per second. At what horizontal distance? Now we are looking for the horizontal distance. And from the cannon with the shell right. So for this case, the horizontal distance is given as v naught d dot. So in order to have the horizontal distance, we need to have the d dot, and the d dot will be solved from the height of the building. So that will be as that you already know. And how long will this take? Now we're looking for the, should be that of, by the way, let me take it back. So we have the height of the building, should be that, and we have the launch velocity as that one, and a question part, first part we're looking for the horizontal distance, which is given as that. But in order to have the horizontal distance, we need to have the d dot, so which should be actually obtained from the formula for the height of the building. Height is given as the negative half g d dot, and here we'll have the d dot, or that will be substituted here. And the other question says how long will this take? Now we're looking for the time that we already calculated. We just have to put it on this. A time has already been obtained. We just have to put it on the question. What will be the shell's velocity as it strikes the ground? Now we are looking for the velocity. Should be landing speed and the direction, much as we have Vfx as well as the Vfy. So this we already talked about. So that's how you start to understand about this case of the projectile motion, which is that of the top horizontally released ground. Let's now extend our discussions by looking at another case of the projectile motion, which is top up angle released ground, where the object is released from the top of a building with height h and at an angle and back to the ground. Let's say this is the launch angle and this is the launch velocity. And the object Stromo will strike the ground with the final velocity along x and the final velocity along y. That is Vfy. And we'll have the landing speed and also the landing direction. Landing speed being calculated in the same way: Vfx square, Vfy square, and the direction, which is the angle theta, tan inverse of Vfy over Vfx. We'll have that. And as you can see, this is not the symmetric case, something different. The same way we talked about it in a freeform motion, we had the symmetric case and also top up ground case we talked about. It is the same way we have to understand here. So just having this side, this is top up, actually this is a symmetric motion, a ground up back to ground, but just down here is something different. So whatever I'll be talking about above there, it is the same analysis we discussed about the symmetric motion. But now in this case, the initial velocity along y, x, will be given as v cos theta, v naught cos theta. Even the final velocity will also be said as v naught cos theta. That's the final velocity along x. And the final velocity along y, have it as Vfy is equal, negative g t dot plus the initial velocity along y, which is v naught sin theta, because now we can have to resolve this into v naught y is equal v naught sin theta. We'll have that understand. So keep that in mind. And how can you have the time for the whole entire journey, which is t dot? Should we say it is t dot will be equal to 2 times t max? No, should not be that, because this is not the symmetric motion. And the time for the whole entire journey will be calculated using the height of the building. And by the way, the total displacement of the journey, it is given as the height of the building. So the height of the building is equal, since this is along y-axis, initial velocity along y, which is v naught sin theta times t dot minus half g d dot square. So this is the equation that we're going to use to have the d dot in case we have the final, actually in case we have the height of the building. So should be that. And let's see how we can have some questions to do with this case of the projectile motion. And now let's appreciate this typical question as how a projectile is fired at an initial velocity of 5 meters per second at an angle of should be that above the horizontal from the roof of a building 30 meters high. So that's, you can see, let's say this is a building 30 meters high. That is the height, 30 meters high, and the object has been released, at an angle. Should be that, and the angle is given as 30 degrees, and the launch velocity is given as 35. So should be that. Now the question A says we should have the maximum height of the projectile. Now that particular maximum height, we mean from the ground level up to the maximum position. We are looking for this, and that is the height of the level of the throne plus the height of the building. We can have that one, of which the height from the level of the throne, of which from the level of the throne to the maximum position, we already discussed about this kind of the height. That will be given as, by the way, overall height is the maximum height, which is equal to the height from the level of the throne and plus the height of the building, which is the overall height from where it reaches at the maximum point to the ground. But the one you need to have is to have the height from the level of the throne, which is height is equal to v0 square sin square theta over 2g. Upon having that one, put it here, you have the height of the building, you put it here, you have the maximum height. That is the height from here up to the ground level. So keep that in mind. And how about the question B? Question B says that we should have what is that as, question B says we should have let me just have to create some spaces here. Now question B says that we should have the time to rise to the top of the trajectory. We are looking for the Tmax from here up to here, and since this typical case up here it's symmetric case, then the Tmax we already talked about it as v0 sin theta over g. And the question C says that we should have the total time that the projectile is in the air. We're looking for the t total. But now for this case, since we are considering the whole journey from here up to here, then the total time won't be 2 times Tmax, because the motion, it is not symmetric. It is symmetric just up here, but the overall motion, it is not symmetric. Hence, the t total won't be equal to 2 times Tmax. So how should you have the t total? T total will be obtained from the height of the building, which is height is equal, negative should be is equal initial velocity along y, which is v sin theta times t total minus half g t total square. And now for this case, we have the height of the building, that is h. That will be given as negative as we'll be substituting it, and we're looking for the t total, so that you can have it as that. And I should also have the velocity of the object as it strikes the ground. So as it will be striking the ground, it will have the velocities in two components, along x as well as the along y, vfy. And the velocity along x is the same as the velocity initial velocity along x, which is v cos theta. And the velocity along y will be calculated from the same formula. Vfy is equal to negative g d total plus v0 sin theta. We'll have the landing speed as well as the direction, which is that one. So you should have to understand it in that way. Now let's say this is the question as well. The question says that a ball is thrown from a bridge 100 meters high at an initial velocity of that one at an angle of that one above the horizon. Now that is we are talking about the same case whereby the ball is thrown at an angle to the ground. The angle theta is given as should be 50 degrees. The launch velocity is given as should be 30, and the height of the building is should be 100 meters. It should be 100 meters. Now we should have how high the ball goes. Now we are looking for the overall height, so that we can have the height plus the height of the building. So how should you have this height? The same way we talked about the symmetric case. And the question B says that we should have the total time the ball is in the air. Height of the building is equal to initial velocity along y, which is v naught sine theta, times d rho and the minus half g d rho square. And for that case, we have the height of the building, which is that will be substituted as the negative. Then we have all these. We'll be able to solve for the d rho like that. And we're looking for the maximum horizontal distance that the ball travels. That is the horizontal distance, which is given as horizontal distance is equal to v naught cos theta times d rho. We cannot say horizontal distance being the same as the range will be given as v naught square sine 2 theta over g, because this is not the symmetric case of the motion. So we only use this when it is symmetric. And at the velocity of the ball as it strikes the ground, we are looking for the landing speed as well as the direction, of which landing speed vfx, which is the same as the initial velocity along x, vfy, that is to be calculated from the formula vfy negative gd rho plus the initial velocity along x. You'll be able to have that, and we'll be able to have the tan inverse of whatever as the direction, the way you know it. So that's how you start to understand about this case of the projectile motion, and of which we are remaining with this case of the projectile motion. And that I beg that you should have to go through that one. Actually, in the video I explained about it. So we have this other case of the projectile motion, where the object is released from the top of the building, below the positive x-axis at an angle theta. Let's say the building is of height given as h. But anyway, for the sake of interest, the initial velocity along x, we'll have it as v naught x is equal, we'll have to resolve that into components v naught cos theta. But the initial velocity along y, v naught y, will be given as the negative v naught sine theta, because it is pointing downwards. That's why it will be negative. And the horizontal distance given as hd will be equal to that of v naught cos theta times the d rho, because the velocity in x does not change since acceleration is due to the gravity itself. And as it strikes the ground, it will have the final velocity along x and also final velocity along actually y. Should have that one. And how should you have the final velocity along y? Principle remains the same. Negative g d rho minus. Now we'll have the minus because the initial velocity along y is negative, minus v naught sine theta. Should have that one. And we can be able to have the landing speed. That is also can be able to have the angle of landing angle like that. And the height of the building can also help us to have. We can also have the height of the building from the displacement formula, negative v naught sine theta, that is the initial velocity along x, along y, which is negative as it is pointing downwards, times d rho minus half g d rho square. We can be able to have the damped x for the entire journey, or the height, if we have all the necessary information. And basically the questions corresponding to this case of the projectile motion, they literally show, and let's say for this case, if it is that one, it literally shows that, the velocity is the object is released below horizontal axis. So you should be very careful at that point. In this one, you do this on your own. Let's say the object is released at an angle theta, let's say 50 degrees, with the launch velocity given as, let's say, 9 meters per second. Let's say the height of the building is given as 20 meters. So you should have the horizontal distance. No, you should also have the total time for the whole entire journey. We should also have the landing speed as well as the direction. So try to have that. Should you have any problem, just have to, give a comment in the comment section below. But you can also have to access me through my WhatsApp number, which is 099-727-2626. You have to get in touch with me. That's my WhatsApp number. That is. So now let's be talking about what we call as the relative motion, relative velocity. So relative motion, it is the movement of object with respect to something else, and that is a frame of reference. So relative motion, it is the movement of object with respect to the frame of reference. So that is what we call as the relative motion. And the relative velocity, it is the velocity of an object with respect to the frame of reference. That is what we call as relative velocity. So on the relative velocity, you should have to understand about what we call as the Gaussian transformation velocity theorem. Let's say if we have 3 frames of references, A, B, as well as the C. Now, what is the velocity of A with respect or relative to B? Now for this case, a B is said to be the frame of reference. So using the principle behind the Gaussian transformation velocity theorem, it states that, as you can see it here, basically I regard this one as a parent and this is the daughter. So on this case, velocity of A relative to B, it is given as velocity of the one who is a parent here will also be a parent here. And the one which is missing here will be the daughter here, that is C. And the plus velocity of the one who is a daughter here will be the parent here. The one who is a daughter here will be a parent, actually will also be a daughter here. That will be given as that. So this is what we call as the Gaussian transformation velocity theorem. And let's say we have VBC. Now for this case, it means we have V, the parent here will also be a parent here, that is B. And what is missing here? We have it as A. And the plus, what is a daughter here will be a parent here. And who is a daughter here will be also a daughter here. This is what we call as the Gaussian transformation velocity theorem. And by the way, we just have this. And for that case, we can have something about, let's say if we have the frames of references 1, 2, let's say 3. Now what is V12? We'll have it as V13, the one missing here, and plus V32. And V32 will be given as V31 plus V12. How about let's say if we have V21? This is the same as V23 plus V31. We'll have it as that. That is what we call as the Gaussian transformation velocity theorem. So relative motion can be in 1 dimension or the 2 dimension. You should also have to understand that if we have VAB, this is the same as negative VBA. If we have V12, this is the same as negative V21. VCX, this is the same as negative VXC. So keep that in mind. And for the case, let's say if we have the VAB 6 meters per second, and let's say we have VAC, which is given as, let's say, 7 meters per second. So as you can see, we have 3 frames of references. What is V, let's say, BC? What should be the velocity VBC? So while using the Gray transmission velocity theorem, we'll have it as, VBA and plus, we should have it as VC, should be VAC. We should have it as that. But VBA, do we have VBA here? No, here we have VAB. Therefore, this is the same as negative VAB. And we have VAC. Do we have VAC? Yes, but it is going towards the left. We'll have negative VAC. Now for this case, we'll have negative 6 meters per second minus, should be 7 meters per second, which is negative 13 meters per second. So that is the velocity of B relative to C. And let's say if we have, let's say this case, let's say have VCB given as, let's say, 2 meters per second. And we have, let's say, VAB, which is given as 5 meters per second. What is VAC? So VAC is given as, VAB and plus VBC. Do we have VAB? Yes, we have it as VAB pointing up, that is positive. No, have it as positive 5 meters per second. Do we have VBC? No, we have CB. Therefore, it has to be negative 2 meters per second. That will be given as 3 meters per second. That is the velocity. So how about if we have in 2 dimension? Let's say if we have VAB is given as 2 meters per second. And let's say we have VAC given as 6 meters per second. Now they are in 2 dimensions because the one is in X, the other one is in Y. What is V should be VBC if that is the case. So VBC will be given as, VBA plus VAC. But now, what is, do we have VAB, VBA? No, we have VAB. So therefore, we'll have it as a negative VAB. And do we have VAC? Yes, that is VAC. Now we should have to resolve this into components. We should have VAC in components. So that will be given as the X component will be given as 0, and the Y component will be given as, should be 6. It is pointing up to be positive meters per second. We should also have to resolve this into components. We can have it as, what is the X component? VABX will be given as 2. It is pointing towards the left, or okay, right horizontal, and the VABY will have it as 0. Therefore, we should have VBC is equal to, we should have to substitute this with components as well. That is, now we have it as something about, so what is that one? So we have negative VAB with its components. We have 2 and plus 0. That is should be around X. By the way, we should have this one as I, and this is J, and this is I, and this is J. So we have 2I and plus 0J height, and should be plus, we should have it as 0I and plus 6J. Then I'll have to distribute negative. We'll have negative 2I and minus 0J and plus 0I plus 6J. We should have to combine J's together. Have negative 2J plus 0, that is negative 6 actually J. That is VBC in unit vector notation. But as a magnitude, as the velocity, we'll have to have the magnitude of VBC, that is a square of negative 2 square and plus negative 6 square. Will have the magnitude, and the direction will be the same as the tan inverse of, negative 6 of a negative 2. So it is the same way we discussed about adding vectors complementary. It is the same way we should have to understand. You just have to refer to that one. Principle remains the same. And also, for more information, you should also have to refer to the video I explained about relative velocity in 1 dimension as well as the 2 dimension. It is a full detailed actual lesson that you should have to watch that one. Thank you.